Hello and welcome to the Lab Online. Today we are doing a demonstration to show you exactly how rock candy is made. So let's start by gathering our supplies. The first thing you're going to need is some kind of heat source. I have a hot plate and a pot, but you may use a pot on the stove. If you're a kiddo, just remember that you will need an adult to help you boil some water. I also have a spoon for stirring, and it might be a good idea to have a napkin nearby just in case, because that spoon's going to get very sticky. I also have some water in this container here. This is about 3 or 4 cups of water. We're going to use between 2 and 3. Just have it nearby. Optional is food coloring. You might also have liquid flavoring. And we're going to need a jar. It needs to be tall, as well as a wooden skewer and a clothespin. We're going to use this to hold the wooden skewer in the jar. It should sit on top. And actually, the mouth of my jar is too wide, so I'm going to use a wooden stick to help it sit on top. You can see how this sits on top of here and just kind of holds the wooden skewer in place. You're also going to need a measuring cup. I have 1 cup here, and lots and lots of sugar. You're going to need probably between 6 and 8 cups of sugar, so keep that in mind. It takes a lot of sugar to get this demonstration done. Okay, let's start our preparation. The first part is very, very boring and time-consuming, but we're going to have you add water to your pot. You're going to add between 2 and 3 cups of water to your pot and bring it to a boil. Going to measure it out 1, 2, 3 cups. I use 3 cups here. You can use 2 cups. It's really going to depend on the size of your jar that you're using. If you have a smaller jar, you might only need to use 2 cups. If you don't have a lot of sugar, you're going to want to use less liquid. It's going to be a while for our water to boil. Mine doesn't boil very fastly on this hot plate. It might boil much quicker at home, so be sure to keep an eye on it. But you'll see here I am wiping out my measuring cup. I just had liquid in it, and now I'm going to use it to measure my sugar. So if I have liquid in it and I put the sugar in, it's going to stick to the sides, and I don't want that to happen. So I'm going to take a paper towel and wipe it out really well. And we're going to sit and bring it to a boil now. And while we're doing that, I want to ask you, does anyone know what temperature water boils at? What temperature does water boil at? The correct answer is 212 degrees Fahrenheit, which translates to 100 degrees Celsius. So that is the boiling point of water. So we are waiting for our water to reach that temperature. And the reason we're doing this is because we are going to dissolve our sugar in our water. And sugar naturally dissolves in water. It is crystallized, and when we add water to it, its molecular structure is going to dissolve, and it is going to become a liquid in that water. It's going to combine and create a syrup. When we heat our water, sugar dissolves faster in it because we're adding energy, we're adding heat is energy, to that water, and it makes the molecules gain energy and thus move faster. And as they move faster, they come into contact with the sugar more often, causing it to dissolve faster. So that's what's happening when we add our sugar to boiling water. Now, if we added our sugar to just regular water, it would dissolve. But by heating it, we're allowing it to dissolve more quickly, and we're tricking it into absorbing more sugar. This is called supersaturation, and we'll talk about that in just a little bit. But what we really want to do now is just make sure our water comes to a boil, 212 degrees Fahrenheit, before we do anything else. Fast forward a little bit, I've been watching my water. You can see it's steaming now, so my water is boiling and we are ready to go on to our next step. So what we're going to do is we're going to add our sugar now to the boiling water. The amount of sugar we add is going to depend on a few things. It's going to depend on the amount of water we initially started with, but it's also going to depend on the temperature of our water. So as I said before, if we have cold water, you're only going to be able to add a few, maybe not even a few, maybe 1 cup of sugar and dissolve it. But if our water is boiling, we should be able to add more than just a few cups of sugar. The hotter the water, the more sugar we will be able to add. And as I said, we are tricking the water into absorbing the sugar. We're creating a syrup. So we're going to start with 1 cup at a time and dissolve that cup of water before adding another one. So here's my 2nd cup of sugar I'm going to add. It goes right in the pot. I'm going to stir it to help the process. And you might want to pull out your spoon and look at the water sugar mixture. If you can see crystals, it is not fully dissolved yet. So keep stirring it for a few minutes. The more cups you add in, the longer it's going to take to dissolve. So I'm about to get ready to add my 3rd cup. My 2nd cup already taking a little bit longer than the first. And the 3rd cup is going to take even longer to dissolve. You might also notice your solution changing color at this point. It's going to go from clear to almost a pale yellow color, and that's the syrup being created. That's the sugar in the water dissolved. You might notice the feel of the solution getting thicker. You might feel more resistance against the spoon as you stir. I used 3 cups of water though, so I'm going to be adding at least 6 cups of sugar. So I'm going to keep adding my sugar and dissolving it. You will do the same. The biggest thing is to keep an eye as you add the sugar and stir the sugar on whether or not it fully dissolves. So if a cup of sugar fully dissolves, add another. But if you are waiting a few minutes, say 5 minutes of stirring goes by, and you still have crystals of sugar that can be seen on the spoon when you lift out the water, that means that your solution is now supersaturated. And let's talk about what supersaturation means. A supersaturated solution is a solution that contains more than the maximum amount of solute that is capable of being dissolved at a given temperature. Okay, so that means that there is more sugar in our solution than can be dissolved in the water. Once we get to this phase, we need to stop adding sugar. The only way to add more sugar would be to raise the temperature of the water, which is possible, and we can do it. You might even need to do it in case you don't see any crystals forming. I'm adding the last of my sugar here. This is really all that I have left, so I'm just going to pour it in. I might not even reach supersaturation in this experiment, which is good because I have another one going and we can compare the two. I'm going to stir it in. Now, why is supersaturation so important? It's part of the reason we can grow these crystals on our stick. So There are two different things that contribute to the growth of the crystals. You have created a supersaturated solution in which no more sugar can dissolve at a particular temperature, and then you're allowing it to cool. A supersaturated solution is unstable, which means that it contains more solute, in this case the sugar, than the actual liquid. And so the sugar will come out of that solution eventually when it cools down. We've tricked it into holding more. Now we're going to trick it into letting it go, and it's going to cling to our stick. It is creating what we call a precipitate, and this is a method called precipitation, which you might have heard when we talk about the water cycle and rain. So the other thing that's important that's going to happen is evaporation. Our water is going to evaporate a little bit, and that's also going to help us form the crystals on the stick. Now is the time to add any food coloring or liquid flavoring you might desire. I'm adding 2 drops of red food coloring to create a pink hue for my rock candy. You can add more food coloring than this, but I wouldn't do more than 8 drops. I'm afraid that if I add more than even a teaspoon of liquid, it might change the chemistry of my solution, and I might not see the crystallization I want. Okay, now I'm taking it off the heat and letting it cool, preparing some space for my jar to sit. It's going to need to sit undisturbed for at least 24 hours before crystals start to form. Put it back here with the other one, make sure my stick is ready, and then I'm going to very, very carefully pour my solution into my jar, almost all the way up to the top. You may want to use a funnel for this for easy cleanup. It's very sticky, so be careful. And then I'm going to place my stick in the solution. And I want it to be as close to the center as possible with a little bit of space from the bottom. I want at least an inch of space between the bottom of the jar and the end of the stick. You'll see it's really easy to adjust with the clothespin, but like I said, I want at least an inch between that bottom of the jar and the stick, and then I'm ready to let it sit. So now it's going to sit for 24 hours, and we will see what happens. As you will see, I have 2 solutions actually set up, and I don't have the results right away for you. Check back in the next few days on our Facebook or Instagram to see our rock candy, and until then, keep experimenting.